Okay, now we want to find the exact values of the 45-degree angles that are in between the quadrantal angles. So that would be here, 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 and here. To do that, I look at this 45-degree angle and I need to do a little geometry. I have a 45-degree angle here, and if I drop a perpendicular here, because remember I need to know what these coordinates are. So I'm going to drop a perpendicular here, and let me go out here and blow up this triangle. I have a right triangle, and that doesn't look very much like it should look, because if this is a 45-degree angle, which I know because they tell me right here, then this has to be a 45-degree angle because what I know about right triangles. And I also know that this side is 1 because it is a radius of that circle. So that means the hypotenuse is 1, and I don't know what this is, but I do know if both of those base angles are 45, both of these sides must be the same thing. So using the Pythagorean theorem, then x squared plus x squared has got to equal 1, and so 2x squared is equal to 1. So x squared is equal to 1/2. So x is equal to the square root of 1/2. And the square root of 1/2 is 1 over the square root of 2. And again, I'm not supposed to leave radicals in the denominator. So when I rationalize that, I get the square root of 2 over 2. So I know that this point right here has an x-coordinate of the square root of 2 over 2. Now, since I know that this side right here of this triangle, that was what I was calling x, is equal to this side right here, which I also called x, but you can see that's the height of that point, so that would be y. That's an isosceles triangle, so both your x and your y coordinates are the same. So they're the square root of 2 over 2 for that 45-degree angle. Now, because of symmetry, I don't have to go through all that geometry. That same point over here in the second quadrant will have a negative x value, so it would be the negative square root of 2 over 2 and positive square root of 2 over 2 for the y. And down here, that 45-degree angle that is in the third quadrant, both the x and the y coordinates will be negative, but they'll still be the square root of 2 over 2. So all my 45-degree angles that are in the quadrants are going to be associated with those ordered pairs, square root of 2 over 2, square root of 2 over 2. And here in the fourth quadrant, my x is back to being positive, but my y is negative. So now I have all of the associated points for 45-degree angles, so I can find all of the trig functions for any of those. And in this problem, it says find the exact trig functions for pi over 4 radians or 45 degrees. Well, the sine is the y-coordinate. The sine of pi over 4 is going to be the square root of 2 over 2. The cosine is the x-coordinate. So the cosine of pi over 4 radians is the square root of 2 over 2. And the tangent is the ratio of sine to cosine, or y over x. And since x and y are the same, when you do the square root of 2 over 2 divided by the square root of 2 over 2, you're just going to get 1. And the cosecant is 1 over sine, or the reciprocal of sine. It's also 1 over y. Either way you do it, you're going to turn this 2 over the square root of 2 upside down. And when you rationalize it, you're going to get 2 square roots of 2 divided by the square root of 2 times the square root of 2 is 2, and those 2's cancel. So this cosecant of pi over 4 is just the square root of 2. The same thing is going to happen when you do the secant, the reciprocal of cosine. Secant of pi over 4, you're going to have 2 over the square root of 2, which is going to, by the same math as we did before, turn into the square root of 2. And the last one we have cotangent pi over 4, which is y over x, and it's also the reciprocal of tangent, which is going to be 1.